we're creating a new mint script, we can simply use the create mint function. So we can do this because we know the pair, and the pair, by the way, this guy will be a key pair. So actually let's do this. Let's not just talk about it, let's actually do it. Alright, so we want to work with this library, which changes quite quickly, must admit. So that's why it's good that we do this. Let's just do this. And just to make sure, we npm inst. Connection from DevNet, provide the connection. Then we need the pair, so we need to have some kind of a key pair. Let's see, what do we have from next thing we need is the mint authority. We'll just say, well, we are also the mint authority. By the way, before we provided a signer, which a key pair can be a signer. So here we provide a key pair, but a key pair is also a signer. But a public key, if we just say payer here, then does it just take that? Maybe it's smart enough to just take the public key from that, but to be sure, I would say dot public key just to make sure. Ah, there we go. It finally tells me that the key pair is not a public key, so yes, I am required to say public key here, and the same thing for here. Thank you. Just testing you, just testing you. The next thing is the key pair, so we can have the token key pair in here, because we want the token to live at a certain address, the token mint, that is. And confirm options, I don't think we need that. And the program ID will be the default token program, so we don't need to specify that. That's okay with me. Let's see if that does something. So we are operating on DevNet and we try to create a new token module. which of course makes sense because I didn't properly rename these things. Classic copy and paste errors. Obviously I took this secret in here and then I tried to create onto this key pair, which does not work, but it's good because we can now const token mint address, await this, and then log the token mint address as well, which will not be very surprising what that is. You will see in a second. Boom. Not very surprisingly, this is the address that we found with the Solana keygen grind earlier and provided this as the key pair. So the create mint creates, so far we just created this mint. So far so good. Now this works because we can load this key pair directly from our wallet, because here we need to provide the signer directly. If we, like James writes here, work with a wallet where we just have the public key, then we need to do it manually. We can't use this function anymore, but we need to build the transaction ourselves, create that account, and then create initialize mint instruction from the token and provide those things. And when we then send the transaction manually, there we can then sign with the wallet. So far so good. I think I don't need to copy that code in. It basically does the same thing. If we then send that transaction with a connection, then we get the same result. Now, next thing, a token account. So far we have a token mint account, but just a token account. Remember, that's the one that holds the tokens. How do we do that? How do we create these? Wow, wait, there's a create account function that we can just call. How easy again. Yeah, way too easy. But just to recap, the token account stores which mint, so which token it represents, who the owner is, so the authority to transfer, burn, etc. And it also stores the amount of tokens. Again, we can see that here. It also does a bit more. You can also have a delegate amount and the close authority. So anyway, with a create account function, we can just create a token account. Wow. What do we need for that? A connection again, a payer again, the mint. So this time we need to say which token it is, who owns that token account, and then again, same thing as before, we can optionally say at which address this token account should live. Does James ever talk about associated token accounts? Yes, he does. Okay, so that's for later. Let's first understand just the token account. Yeah, let's just do this. Although, before we do this, let's check what happens if we execute the same code again. Then we will see the same error again, 0x0. And that just means, oh, I cannot create a token for you at this address anymore. Well, obviously, because at this address there is already something stored. So we can't do that again. The way we would need to create a new token is to provide a different address here that is not yet used, or not provide this key pair here in the back. Then we can just create another token. I will select a random new key pair, and then we'll also get back that is now a random address where it created the token, right? We can also look at that. Once again, we will have a random unknown where we are. Okay, now back to this. Let's not create a new token, but create a token account. So create account. We do this, provide the connection, we provide the payer, so who pays rent and the transaction fee. We say which mint, so this is the token key pair public key now. Because remember, that's just this address. We could also just create a new public key for this address, but it's in that key pair, so I'm going to use that. Then what else we need? The owner, let's say we create it for ourselves, so we take our public key, and then we can token key pair public key. Now, because remember, that's just this address. We could also just create a new public key from this address, but it's in that key pair, so I'm going to use that. Then, what else we need? The owner, let's say we create it for ourselves, so we take our public key, and then we can once again specify a key pair, or let's get another one, my token account, or just token account to make it quicker. There, TA for token account. Also have to know that, you know, at that point it would make sense to create a function for this, Andy. Let's take this. Returns me a key pair, and then just say this, and account. There we go. And we can provide the token account key pair here. Now, if we execute that, well, maybe promise of create account function is different from the create account function shown above when we, under the hood of the create min, use the create account of the system program. Yes, but that's a different one. We are now from the SPL. Yeah, so that's just something that we find in here again. You know, if you want to have a look in the actions, create account, no close create here. That's what it does under the hood. If we don't provide a key pair, then it does the ATA, the associated token account. We'll get there in a second. But then we just get the information for the mint. We need to know the decimals, find out how much space we need, then find out what the rent exemption for this is, and then create the account. So this is a different one now. This is the one from the system program, and create initialize account instruction. That's with the token program. So that is an instruction of the token program that we then actually send, and we get the public key back. I mean, we can pretty much ignore it, or we can wait it just to have something that we print as a result to see that it worked. There we go, and surprise, surprise, it gives us the same address back as we put in up here. And if we have a look on the Explorer, then we see that this is now a token account because it's owned by the token program. Explorer doesn't even tell us this anymore. It tells us this by saying it's a token account because the owner of the account is the token program, but the owner written in the account, that's the actual authority. So this field should be called something like authority, not owner. But you know, back in the days they named it that, so that's what it's still called. It's still Jamie. Yep, right. So we have a token account. If you wanted to do that manually, we already saw that's how we will do it. Before we need to space the Lamberts though. Now, before we start to mint tokens into our token account, I want to discuss associated token accounts. Because each of the token accounts that we create, they have an owner or an authority. But now, whenever somebody sends me tokens, they could create a new token account to do that. So create a new token account, put the tokens in there, and you're the owner of that. Problem with that, obviously, is that one person, aka one wallet or one address, will have several token accounts for the same token mint. For different mints, of course, you need to have different token accounts, but even for the same mint, you can have different token accounts. Like, I could go ahead and create another one with another key pair here and still put in the same owner. And that's inconvenient if you then want to transfer tokens, because they live in different token accounts and you need to have one transfer instruction for each of them, which is annoying. So people came up with the concept of associated token accounts. Now, what is an associated token account? It's essentially one account for a particular wallet and mint. So we derive an address, similar like we do with the PDAs, so you should be familiar with that concept, and we use the owner's public key and the token mints as seeds, you know? So this is deterministic, aka we will always be the same as long as we provide the same owner and mint, and it will return us a specific public key. And in 99% of the cases, you just want to interact with the associated token account, also called the ATA. If you hear Solana people talk about ATAs, that's associated token accounts. Because whenever I send somebody some tokens, I want to send it to their ATA. And this SPL token library already makes it super easy for us. We can just say create associated token account. Then we just don't provide the key pair, right? And the shortcut of this is not providing a key pair, which calls the create associated token account. Let's have a look where we find that and what it does. Okay, so it's a different instruction because there's also an associated token program ID. Yeah, so there's an entire program that is used to handle these things. But you can just do it yourself manually. There is a specific way how you derive associated token accounts, just that this program does it automatically for you. If you wanted to know how, you can once again go here, go to the associated for the token program, create the account, and we initialize account 3, version 3 already. Okay, things change. Moving on, I think you understand the concept of associated token accounts, you understand the concept of token accounts, token mints, and we can be moving on to actually mint. Ah, wait, so no, let's stay here for a bit longer because we just talked about the get or create associated token account to get the token account associated or check if it doesn't exist. So this we're in, like we just looked at that, but that will also just query code and allow owner of curve just says, remember of curve is a PDA. If I allow a PDA to be the owner of this ATA, which we can say false or true or leave it out entirely. This will now be our ATA. It was already before an ATA, but situation. And here we get back the account itself, and then we just get the address of the account. And this should now work every time because it will just check if the account is there, and if it is there, then it's it. So that's why it's quicker now. We don't need to send anything. Only if we had a different token or a different owner, then this method would also create the ATA for us. I guess that's understandable. At least I hope so. But we can dig deeper though, because what that does is just it creates an associated token account if it doesn't exist yet, using the get associated token address to derive the associated token account address. Now this thing, creating it as well, we can say our associated token account is get associated token address of our mint for this pair, and that should then also return us the same thing. There we go, 51YF. There we go, nice. I even have the implementation here, so I don't need to go on GitHub. And maybe I just have an old version. That's the mint TS. So it's a state mint TS. State mint. Yes, that's the thing. Yes. That we also have here now. That's how you derive the address, because it's literally using the same thing as we saw last time, find program address sync. So same thing we use for PDAs, and we put the O amount of tokens outside, not accounting for decimals. So you need to account for decimals. So say if you have 0 decimals, then you can just put in the raw amount. If you have 1 decimal, then you need to multiply it by 10, because decimals 10, got it? And if we have 9 decimals, then we need to multiply by 10 to the power of 9 because decimals. So compare lamperts, you want to put in the amount in lamperts and not in sol if we put in the amount here. Yeah, let's do this. Mint 2. We have our ATA and we signature mint 2 from the SPL token library, provide a connection, provide a payer, provide the mint. You know what? Common practice is to call this mint, and we just, to make it easier for us, now call this mint. So that's just the public key of the token mint, so we just can write mint here. And then the destination, we provide the ATA, so we want to mint it into the associated token account. We could also provide, the other token account that we had here. Mint it in this one. Of course, I had the wrong token keeper, of course. We could also mint it into this one. Anyway, good that I scrolled up there. Found an error. Then the authority, we are the authority because remember this guy, oh wait, the account, sorry. If we go to the token, the authority, this guy, only this guy can mint, so we need to say we are this guy. And the amount, this number, let's just say we want to mint, I don't know, 3 tokens, and then we need to multiply that by 10 to the power of decimals. No, and our decimals we hard coded as 9 here. We could have done this, and so 3 times 10 to the power of 9. If we do that, let's also log our signature so the ATA exists and stuff. And let's see if we get a signature. Yes, we do. Works. We can check that out where we see we've paid. So this was the payer. 3 tokens, and in the entire amount it was the 3 with that many zeros, 10 to the power of 9. It was just a mint2 transaction, a mint2 instruction on the token program. Yep, pretty simple, right? I think there's so much more stuff. Anyway, Solana is developing quickly. Yeah, and that's how you mint tokens. It's so freaking easy. Where are the good old times when people asked me to mint tokens for them because they didn't understand. Okay, moving on. What does James say? It's not uncommon to update the mint authority on a token to null after the tokens have been minted. Yes, that's how we create a fixed supply. Otherwise, you know, we could keep minting tokens as we like. Again, if you want to look under the hood, there's just a create mint2 instruction on the token program. Yeah, so that's also part of the token, SPL token. If you create a mint instruction, put it in a transaction, send that, that's essentially all that happens. Right? Simple. Okay, keeping it as simple as that, transferring tokens. Once again, we're literally just calling functions. What does transfer do though on high level? Well, subtract the amount on one token account and add the amount on another token account, as we had with the system program transfer. The token program transfer does the same thing, but on a token account level, not on an account level. So if we have both token accounts, we can just call transfer. Let's do that. What do we need? Well, the payer again, who pays for the transaction, source, destination, those are the token accounts, the owner, so the authority for the source token account. We don't need to be the owner of the destination token account, can be, we don't need to. And the amount, again, with decimals that the account is for. So let's do that. Let's send it to our other token account. I'm just gonna do that because we already created it, so let's do an STA. And usually we would have a different receiver, but I'm lazy, so I'm not gonna do that. I'm gonna ignore that for a second and say our signature is now awaiting just a transfer from the token program, again with connection, payer, source is now our ATA, destination is now our token account, and of course the owner or signer, let's say it has to be the payer, I'm just being tired, and the amount, let's say 1, just so you see what happens if I type 1, okay? This is not going to be 1 token, because 1 would be 1 times 10 to the power of 9, but we want to see what happens if I just have 1. So again, maybe just log this and give it a go. Again, it's this very basic token program interaction with the simplest functions. If we have a look what's happening here, we again pay for 1 transaction. We need to specify the accounts that we operate with, so source, destination, and the token program, of course. And now look what happens. I transferred 1, but 10 to the minus 9 tokens, so just 0.0000001 tokens to the other token account from my associated token account. And that's the result. Just so you start to understand what's happening here. If you're doing this and you would expect a 2 here and a 1 here, then you forgot to multiply the decimals into your amounts field. Yeah, but again, just 1 instruction on a token program, this time a transfer instruction. Total supply can be decreased. Of course, we need to have the authority for the account, and we need to say how many tokens we want to burn. So let's say I'm unhappy with how many 9s there are and I want to burn them all. Burn them all! I go here, calculate my amount to burn as 1 token. So we burned all those 9s to have a clean 2 tokens. Yeah, and it's done by just another instruction on the token program. Who would have thought? The burn instruction, and that's it. Pretty simple, huh? So we can create token mints, create token accounts, create associated token accounts, mint tokens, transfer tokens, and burn tokens. Yay! We can build dApps now, because that's all you need. You like token, right? With that, you can already do quite a lot. So what else is there to learn, James? I mean, that's pretty much it, right? Oh, you want us to do stuff ourselves? Man, I thought we were done now. So, demo. So what James does here is just creating a new project in a certain way, which I think my big main function is just good enough. But just to learn something, I want to see what that actually does. What does that thing do? Oh, it will also create me a package JSON and everything. Okay, then give me an index for a main, which already creates as a connection and initializes a key pair, which we have here. Right, so that's stuff that we learned earlier, right? And we airdrop some soul if we need that. Yeah, I mean that's nice preparation, James, for somebody who just wants to get started with something. But since I did the previous lessons and I have pretty much all of that already here, I'm good with that. So, and then all he does is create so essentially, pretty much the same. Test it all out, right? So he creates a token, creates a token account, mints tokens, creates a new receiver, creates him a token account. That's the thing we didn't do, but we could have, for the receiver, we once again need a token account, and then we can put this address source and destination and send them 50 and burn 25. So he just calls the same functions with a bit different values. Not gonna do that again. However, I will do the challenge with you, right? Because this looks like front end and we want to do some stuff. Now it's your turn to build something independently. Yes, my dear viewer, you can now build something independently. You can stop watching this video now that you know so much about the token program. You can use that by yourself. Right? Being sarcastic today? Yeah, maybe a little bit. Not that you will not be able to directly use helper functions we went over in the demo. Oh no, because we don't have the key pair directly. We don't have this anymore. Oh no, we need to do it manually. Oh no. In order to interact with the token program with the wallet adapter, we'll have to build the its transaction manually. At least a little bit of a challenge. Now, what do? We can build this from scratch or start with the starter code? Well, obviously we start with the starter code. Am I crazy building front end? Hell no. So we're gonna starter branch solana token front end. I did not complete this yet, so that will complete cd solana token front end. What's inside this solana token front end? I ask. Token front end. So some stuff that's not important. Probably we're gonna work in here somewhere, right? But we're just gonna then dev to see if that thing starts coming back. Cool. We still have some soul balance from last time. There we go. Enter the token mint. Enter token mint. Create mint. Create mint. It does nothing. Create token. Please fill out this field. Mint tokens. Mint tokens. Please fill out this field. Okay. Create mint does nothing because it's not implemented. Well, let's implement it then. That's the challenge. So download the starter code. Then create a new token mint in the create mint component. Create mint component. You can find this. Create mint component. So let's have a look at this. What is happening here? Build and send. Ah, easy. Just do it here. Insert your code here. The event submit comes in here by event, and if we do not have a magical break here, we should return. Then here we should suggest the edit movement, and if we have a transaction signature equals 70x sig. Well, let's do this then. Challenge accepted. We do the following. We create just that token mint. Put this down. It's so confusing. It's all caps. And what the initialize mint instruction. Oh, we need to execute it in that. Right. So far so simple. Start by to call this signature. This transaction from the wallet with this one. we have to pay 0.00146, which is the cost for the rent of a token mint account. Approve this. This is the keycard. And if I want to create this account, then I need to prove that I can sign for this. So maybe that's my problem, but I also need to add a signer. Let's see if I can Haha, there we go. Yes, nice. And we can click Solana Explorer, and we see the token that we just or the transaction for the token we just traded. All right, that's me. I had to pay this, and that's the token bit. Let's do this 0, and we see here 3 decimals. Cool. So I mean that worked, and the reason why this didn't work is the create account. If we want to make it on a specific pub key, obviously we need to own this thing we just created as public key. We could also, did James do that as well? Did he provide that card keeping message? That's that part done, and then create a new account, create token account. Build and send trade token account transaction here. We already have everything prepared in the import. Well, but I mean, that's cheating, so we're connected with a pub key. Create a token account. Now do pretty much the same thing as we did before. So this stuff, can we remove that for a second? I don't know which mint I should use though. Right, because we put on and we haven't imported mint. Maybe I just get the just value. That's probably not a nice word. Yeah, but I mean, that's how we get the values. I mean, it does what I want it to do. Yep, I guess that's how we get the values.